Hello students, the last lecture we have seen what are the semiconductors. Today we are going to see what is a PN junction which we can form using the semiconductors which we have seen. There are P-type semiconductors, there are N-type semiconductors. So what happens, there is one slab. So in some region we dope P-type impurity, that is, let's suppose boron we doped here in this region, and in this region we dope n-type impurity, or we can say here we dope trivalent impurity, here we dope pentavalent impurity, for example arsenic. So this becomes p-type. This part of this slab will become p-type. This is basically silicon slab and or germanium slab which has tetravalent nature, and this part will become n-type because here we have doped the pentavalent impurities, so one electron is more in each atom. So this will give us the charge carrier as electrons, and this side where we have doped the trivalent impurities, that will give us charge carrier as hole. Hole is nothing but the absence of electron. Now what happens, because here are more number of electrons and here are holes, some part of electron may cross this part. So I will draw a different color now. So the electrons will pass here, and now what happens here in this region, up to this region, from this black line to this red line, there were previously there were holes, and the electrons from this n-type region, in this region, they were crossed this line and reached to this hole, and they recombined. Electron hole recombination, this process is called. So because of this, what happens, the this part previously was neutral because the number of protons were equal to number of electrons. In this region also number of protons were equal to number of electrons. But now what happened, some electron were passed from this region to that region. So because here is now electron deficiency, so this region has become plus, and now this has become minus because there are more number of electrons here. So there is negative layer towards the p type and there is positive layer towards the n type. So this forms, this is called as this forms, because of the charge separation, this forms a voltage. Okay, so if you take two terminal and if you measure the voltage in between, there will be some voltage. So the voltages are different for different materials. This formation, this part in the red region is called as a PN junction, and the whole apparatus, whole slab, we call as a PN junction diode. So why it is called as diode, because now it has two terminals, so this is called as a diode. Now this diode is used in many purposes. If you have seen solar panels, so it has also one diode in the structure. So what does this do, if we supply a positive terminal to the p side and negative supply to the n side, then what happens, electrons in this region may again, because of this additional voltage, they can pass this barrier and come to the p side, and because this is more positive, the electrons here can pass through that because of that voltage, and again some electrons can come towards this side. So the electric current can pass through this diode, and this type of configuration is called as forward biased PN junction. Suppose I have another case where this side is negative and this side is positive. Now what happens? Here is already positive side and here is already negative side. So because of this negative, the electrons present here, this negative and this negative get repulsion. Okay, and therefore what happens is this electron from here will get accumulated here, so the barrier voltage can increase because of this. And if we use the forward bias connection, that is plus to p and minus to n, then the width will decrease, barrier width will decrease. And because of this width, the electrons cannot pass in this type of connection or in this type of configuration where p is attached to negative terminal and n is attached to positive terminal. This is for battery. This positive and negative are for battery. So in this case we call as a reverse biased PN junction diode. When positive terminal is connected to P and negative terminal of battery is connected to end side of the diode, then what happens? The current can pass and the configuration is called as a forward biased. And when negative terminal of battery is attached to P and positive terminal is attached to N, then it is called as a reverse biased configuration. And in this configuration there is almost no current. Some leakage current may flow, which is in nanoamperes, but ideally it should not conduct any current. So this avoids the black backflow of the current in solar panels. So what happens when the solar panel is generating the electricity in presence of solar energy or sunlight, it will produce some voltage. And if in the evening there is no sun, so what happens? It may try to go back, the generated energy may try to go back. So solar cells or solar panel will act as a load. So that should not happen, therefore the diode is necessary there. There are so many applications of diode. Now there is one more electrical device which we call as a transistor, or this is also called as a triode. So previous one was diode because it has two terminals, di means two and tri means three. So in the transistor we have three different terminals. So what we do here, I am just drawing one type of transistor here. So here we have this region. So basically this slab is already n type semiconductor, and in the region we adopt p types. Sometimes it is reverse, so sometimes this is p and this is n. So what we do here, we draw three connections from here, one here and one here. This is the basic diagram, block diagram. So there are names of this. One is called as source, one is called as gate, and one is called as drain. Okay, now there are different concentrations at different regions. In diode also there were different concentration. P, the concentration of P side was less and the concentration of N side was more. Similarly here is also different concentrations are used. So in the N type itself there is higher concentration at source, P has the lower concentration, and again this drain side N type is also having less concentration. The transistors can be used as a switch, or sometimes it can be used to amplify the signal. So there are different regions in the transistor. So this here you can see this is a PN junction diode. This part is called as PN junction. So at particular voltage what happens, if the voltage is low then this will not conduct anything, or if it is connected in reverse bias, then this PN junction diode will increase its weight, and this is designed such that this will cut off this region, so there will be no current at a drain. So this is the basic configuration of the transistor. They may be in different shape or there will be different models. So some of them we call as a FET or field emission transistor, or we call as FET. Now there are this is a type of transistor. Now there are some FETs we are going to see on the basis of metal oxide semiconductor. There are some metal oxides which can behave as a semiconductor, so they are called as metal oxide MOS and FET. Okay, so FET you have seen the definition earlier, that is field effect transistor. So we have different types of MOSFET. Now there is again P type of semiconducting material. If we use, then it is called as a P MOSFET. Okay. Or I will just write PMOS. These are for, this is for the FET itself. Okay, and if we use N type of semiconductor, then it is NMOS. Now there is one Cmos, which is the combination of these two. So Cmos is nothing but complementary MOS. We are going to see what is a complementary MOS and how it is constructed and why we use this type of MOSFETs. So I will show you the diagram. Here you can see, here there are two different regions. This is NMOS. You can see here source and drain are in N type and this gate is connected to the P type. Therefore this is called as NMOS because source and drain both are N type. And here you can see PMOS, where source and drain are in the connected to the P region or drawn from the P region, and gate is connected to N. And now these are combined. So this is the structure of your CMOS. Okay. Okay, so this type of configuration is called as NPN and this type of called as PNP. So these are type of transistors you can see. Now why we use this CMOS? This is because when we use the ordinary switch or ordinary amplifier, so this transistor does some work of amplification and sometimes it works as a switch. So this is done with very high efficiency, so there is very less power loss. If we supply power, then in ordinary amplifier we have to supply very much of the power, but because these FETs can consume very less power and give very high efficiency, we mostly use this. The other thing is that the size of the FET is very less. So you can see in the integrated circuits, which is very small in size, you can see on the chip there is some circuit, or in some IC there is some circuit. So inside that there is a circuit, and that circuit can be built if the devices are very small. Therefore we can use or we can build such circuit with very small size with the help of this MOSFET. So this is called as a complementary MOS or CMOS FET.